I mean, I like tiny details. I suppose that's why I do this work. But it's sort of like, there's some concept of good enough, isn't there, with programs?
Yeah, yeah. I mean, definitely, right?
Like, it works, does the job sort of
Yeah,
thing. But then there's kind of a world beyond that of like, well, actually, how much better could we make it? If we really aspired to be masters of this craft of software engineering, what would a master do? You know, is there some limit where, basically this is now the optimum program and there's no way to improve it beyond that? I think it's fun to know what that is, isn't it?
yeah, definitely.
Or we can certainly ask that question. I mean, that's not quite the same as saying, as working software engineers, we must always reach that point before we can ever use any program. That would be silly. And we usually haven't got time, or the boss won't let us, or there's some point where we have to say it's as good as we can make it given the time and resources that we have, and we know that's not as good as it could be. But there's also a question of diminishing returns, isn't there?
Yeah, yeah.
So I think that's reasonable, and um, I think a big part of this approach to programming is just, not. Some people might look at this code and say, "Yeah, it's fine," I don't see anything wrong with it. And my answer to that would be, "Yeah, you don't see." There are things wrong with it. The fact that you don't see them is a fact about you, isn't it, rather than the program? I wouldn't put it that rudely, but you know what I mean. That would be the message. Um, and it's basically about learning to see those things, isn't it? And a big part of that is just basically not being happy with stuff that doesn't seem perfect. Any little irritation or extra bit of work that we don't really need to do, or little infelicities in the way things, badly chosen names, unhelpful variables, and things like this. They may all be absolutely tiny in themselves, but these things really add up, don't they?
Sure. Yeah, definitely.
Over a big program, I don't know how many lines there are in this project, but a lot. That all adds up to a big cognitive overhead for the poor people who have to read them, like you and me. Um, and I think Larry Wall, the guy that invented Perl, he said that the key um, aspects of good programmers are laziness, impatience, and hubris. I think this is very well put, because laziness matters because I don't want to do a bunch of tedious manual work. I want to automate it all. Sysadmins and SREs can relate to this.
Mhm.
Just get the machine to do stuff. That's why we're programming. Impatience, because I want it all to happen quickly. I want my program to be efficient and fast, if
Right.
possible. And hubris, because I'm conceited enough to believe that I can actually write correct programs in the first place, in the face of the evidence. In fact, we always end up writing buggy programs, but we must believe in ourselves to that extent at some point in the process to say, I think I can actually do this. Um, and there are some extremely smart people who just don't become software engineers, but perhaps they're lazy enough and impatient enough, but they're just not hubristic enough. Probably makes them nicer people to be around, but less accomplished engineers. But that's fine. And I apply those three criteria to programs that I'm looking at. Um, just as a reader, I'm lazy. I don't want to have to do too much cognitive work reading this code. I want it to be, as my friend Matt Ryer puts it, glanceable. I want to be able to just glance at something and instantaneously perceive what it's for and why it's here. That would be lovely. Doesn't often happen, does it?
No, no.
But the closer we can get to that, the better. And I'm impatient because I don't want to wade through too much boilerplate and paperwork, or have to think too long to figure out what the program does. And hubris, I guess, I just feel like I could do this better. you know, I always feel like that, and I'm probably wrong most of the time, but who cares? So, fine, okay. Closed digression, all right. Um, I'm holding you up, aren't I? But we can see that like the next stanza here is basically about setting all of these FTPD conf fields. This is fine. We feel we know what this is about. It's getting the FTPD server ready to run. So let's scroll on, and we'll see this is more setup, setup, setup. We call at 341. We call ftpd.getStatus. That's some. Wait, is FTPD a variable or is that a package? I think the syntax coloring is saying it's a package, isn't it?
Yes.
Okay, so it's sort of a singleton, isn't it? That's implying there's one server which can be running or not. You can't just instantiate as many servers as you want and manage them independently. That's all right. You wouldn't want to run multiple servers for real, would you? You just run one.
Yep.
Usually in tests it's convenient because you want to run a bunch of parallel tests probably. You can have them all talk concurrently to one server, but that can be a bit awkward. I mean, you'd like your server to handle that, wouldn't you? Wouldn't be a very good server if it couldn't handle concurrent clients. But the point being, if you want to assert things about the server's state from those tests, imagine you had a test which was like test upload. You connect to the server, you say upload this file, now list files, and I should see that file I just uploaded. Great, that's a nice test, But suppose some other test is running concurrently and it's like delete file, and it concurrently deletes all those files, and then when the first test looks, it's like, hey, that file I uploaded has gone. What's going on? All the tests start interfering with each other because there is in fact some state in the server. Anytime you've got concurrency plus shared state, that's a recipe for confusion, isn't it?
Right.
So, welcome to the exciting world of concurrent programming.
Right.
So, fine. So we call ftpd.getStatus and we assign that to the status variable. Okay. And then we say if status.isActive, so looks like some Boolean field on some struct, doesn't it?
Yeah. Yeah.
You could imagine that the status was just a bool, couldn't you?
Mm-hmm.
And then it would be like is running. ftpd.isRunning. If ftpd.isRunning, then do stuff. But they haven't done that. Maybe there's other fields on the status that we don't know about. But basically it said, what is the status of the FTP server? If it's running, then log an error message, FTPD is already active, and bail out. So I guess it's like, we're going to try and start the server as part of these tests. If it's running already, that's a problem. Because as we saw earlier, there can be only one. So I guess that's why we check that. Okay, so what's next? So this looks fun, doesn't it? Because we have a go statement.
Yeah. So there's go and then func, and it's setting it up as a logger.debug, and it's taking the log sender variable as well as a empty string and a string initializing FTP server with config %+v.
Yeah.
And finally the FTPD conf variable as well.
Yeah.
And if there's an error, if error equals to ftpd conf.initialize config error not equal to nil, then go ahead, output an error using the logger.error to console.
Yeah.
Could not start FTP server, and then it does an OS exit.
Yep. So yet another initialize.
Mm-hmm.
There's no shortage of these, is there?
Yeah.
So this is fine. So this is inside a go statement. So have you used a go statement before?
No, I haven't.
Yeah, it's surprising how few people have. I mean, you'd think you'd be doing it all the time, wouldn't you? I mean, it's right there in the name of the language. But really, we don't actually use it a lot. Most Go programs are actually sequential, that is to say, not concurrent, so not needing a Go statement. And that's great, because, I mean, concurrency is cool and all, but it can get complicated. So sequential programs are much easier to understand. It just does one sequence of things, not n concurrent sequences all operating independently. That's very difficult to reason about and debug. So we definitely don't do anything concurrently unless we have to. One example of where we have to would be starting some server, isn't it?
Yep.
Because what are the semantics of a server? It's usually that you start the thing, it sits there listening and handling connections, and then ultimately at some point in the far distant future, it shuts down, and that's the end. So if you said, start server, then your program would be unable to do anything else because the server would be running, and that's it. So if you want to say, start the server, but meanwhile I'm going to carry on and do some different things over here, that's where we could use the go statement. So it is a statement, we just say go, and then it's followed by some function call. So you could imagine if you had some function called something like start server, we could say go start server bracket bracket, couldn't we?
Yeah.
It's almost like an instruction. Go fish, go run this function. And if we don't happen to have an existing named function that does what we want, we can just construct one. We can construct an anonymous function literal like this. Sounds complicated, but it's just a function that we haven't bothered to name because we don't need to. And the way we write that is just the word func, and then if it takes parameters, we would list them between parentheses, but this one doesn't. And then a curly brace and the function body, and then you'll notice at the end here, we close the body of this function with a closed curly brace, and then there's two empty parentheses, isn't it? So it's like, you could imagine that the way it works is it's just go func, and then here's some function, there you go, just run that. But that's not what it is. Just giving an anonymous function literal by itself does not call that function. It just says, here's some function, do with it what you like. And then by specifying the empty parentheses, that means call it. And if you've come across the defer statement, that also works the same way. You defer some function call. So what are we doing in this concurrent function? We're logging that debug message that you said, and we're calling ftpd conf.initialize, which I guess is the start server method. We check some error from that. Presumably if it can start, it does, and then that call to initialize just blocks. And the server keeps running until you kill it, doesn't it?
Yeah.
But if it's not able to start up for whatever reason, that will immediately bail out. So this is fine. So we now have two goroutines, don't we?
Yeah, let's see, two.
We always have one go routine because we're in some Go program. There's always at least one. We call it the main Go routine, but there's nothing special about it. It's just a regular Go routine. And if we start others with the Go keyword, then there will be more. So we've now started one extra one, so now we have two, and then we're about to start another one, aren't we?
Yeah, yeah.
So exactly the same Go func stanza with debug log, except now we're initializing sFTPD, and then the exact same stuff again, but now it's HTTPD, isn't it? So now we've got three servers, which is getting confusing. So there's regular FTP, that is to say not encrypted, sFTP, which is to say FTP over SSH, and HTTPD, which we all know and love. So fine, so now we have four Go routines, including the one we're in, and what do we do next? So from line 370.
Yeah, so from line 370, there looks like there is a function called wait TCP listening, and it's taking the ftpd conf.bindings 0.get address function.
Okay. Looks like this is a way of getting the FTPD server to tell you what its address is, isn't it?
And then something similar for HTTPD, wait TCP listening, HTTPD conf.binding 0.get address, and for sFTP as well. So
Yep.
wait TCP listening. So yeah.
Well, could we deduce what this wait TCP listening thing is doing? Any ideas?
Um, I guess it's just trying to see uh, what it's listening on, or
Well, it says wait, doesn't it? Which it might give us a clue. And one thing we know about servers is when you start them, it's not going to start instantly. It'll be quick, hopefully, but not absolutely instant. And also because it's in a go routine, as we've said before on Code Club, just because you say go func something doesn't mean that starts happening right now, does it? It's more sort of like, hey, here's another go routine I'd like you to run when it's convenient.
Mhm.
When you have a free thread or a free core or something.
Sure.
Or maybe this current go routine that I'm in blocks on IO or yields for some other reason, you know, then one of these other go routines might start running. We have no guarantee of when that'll be, or even if it ever happens. We hope it will. But so we're presumably in the tests we're going to try and connect to these servers. So if we try to connect now, odds are it's going to fail, isn't it?
Yeah.
Probably not ready yet, or either go routine might be running, but maybe it hasn't quite started up and bound to the port yet. So one thing we're going to have to do for all three servers is just wait until they're ready. And we could guess that's what this does. Just out of the power of your naked brain, what would you do if you had to write that function? Should be relatively easy to write, shouldn't it?
Um,
What
yeah.
are we waiting for, in fact?
Uh, are we waiting for like maybe some status message to come up?
Could be. But even before that, we just need to be able to make some TCP connection, isn't it?
Sure. Sure. Yeah.
Like, that's presumably what the tests are going to do. They're going to try and connect, and it will fail until the server is ready. So one thing we could do is in a loop, we could just say, is it, can we connect yet? Can we connect yet? Can we connect yet? Okay, now we can. Maybe with a little sleep in between times.
Sure. Sure.
Sort of like, for forever or for n tries,
Hmm.
connect to this address. Did it work? No. Okay. Sleep for 1 second, try again, or sleep for 10 milliseconds or something. And we could click through to have a look, couldn't we?
Yeah. Yeah.
We can see if you're right, because I think you are. Or at least I think that's a perfectly reasonable way
Yeah.
of doing it. Yep, kind of looks like it, doesn't it? So we have
Yeah.
some wait TCP listening function that takes an address. We have an infinite for loop, that is to say, a for loop with no terminating condition, so it just runs forever. We call net.dial, which is the please make a TCP connection standard library function. We handle the error from it, and if there is an error, that's presumably because the server's not listening. So we log that fact, and then we sleep 100 milliseconds, and then we say try again, which makes sense. But if there wasn't an error, that means it is listening now. So we're done. So just close that useless connection that we opened purely for testing purposes, and then break. That is to say, break out of this infinite for loop and return. So that's great. So we can go back now, can't we? One
Yeah.
interesting
Sure.
thing about this is we could have done that waiting concurrently, couldn't we?
Yeah. Yeah.
But in fact, we do not. So it's like if you return to where we were,
Okay.
the call to wait TCP listening,
Is there a shortcut to
control dash.
control dash? Oh,
Yeah.
perfect.
So like if you've You know, if you're using VS Code, if there's some function call or something and you hover over it and command click, it will take you to the definition of that function, or right click and select go to definition as you did, and then control dash will take you right back to where you came from. And that's a stack, so you can go deep, 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 and then unwind all the way back step by step.
Nice, nice.
Very useful for Code Club.
Yes.
But yeah, so we can see what they do, can't we? Is you wait for the FTPD server to be ready, and then after that, sequentially, wait for the HTTPD server to be ready, and then after that, wait for the sFTPD server. So we could have run all of these in Go statements, but it doesn't really make any difference because by the time the FTP server is ready, the other ones probably will be too, won't they?
Yeah, yeah.
So actually, we don't waste a lot of time doing useless connections, which is good. I found with one student project that I was helping with, starting an HTTP server, you know, what we did was exactly this: was we said we'll try and connect to it in a loop. Is it ready yet? Is it ready yet? Okay, now it's ready. And then we found when we connected to it in the test, we had in fact screwed up the HTTP client because of all of these repeated failed connections somehow. And I don't know exactly why that is. There's some complex machinery inside the HTTP client, as we've seen on previous code clubs, to do with, you know, reusing connections, maintaining state, being efficient in general. And apparently what we did was inimical to that, and it didn't like it at all. So that's interesting, or not.